I know. So Joel has worked at NASA for 41 years, he served many roles, and all of them the science directorate, either for Langley or for NASA headquarters. Let's see, that includes senior research scientist within our very own science directorate, a program scientist for the Mars Scout program at headquarters, and co-chair of the NASA Human Exploration of Mars Science Analysis Group, which has been planning for the human exploration of Mars. So retiring in 2011, he now serves as a research professor in applied science at the College of William & Mary. And I hope that we have some of his students online today to hear his talk. In 2017, Dr. Levine was also inducted into the Langley Hall of Honors. Today, he will discuss issues based on material in two of his most recent books, Dust in the Atmosphere of Mars and its Impact on Human Exploration, and the Impact of Lunar Dust on Human Exploration. So I now hope that with easy transition, we turn this over to Dr. Levine.
Thank you, Vicki. Thank you for that nice introduction. I know we had some issues with the Zoom connection. I keep thinking that these are the people who 50 years ago were responsible for the first human landing on Mars, first human landing on the moon, and are preparing for the future human mission to Mars. And so I hope we have the skill to provide Zoom to the people who are calling in. It's certainly a pleasure to be here. It was a great experience working at the NASA Langley Research Center. I actually told my wife, Arlene, who also ended up working at Langley for 27 years, that we would move down to Hampton, Virginia, so I can accept this job. And in 5 years, we'll go to a university. Well, I ended up supporting Viking and doing models of the Mars atmosphere for Jerry Sullivan, the project scientist, and that those 5 years stretched to 41 years. But after 41 years, I told Arlene we would now go to a university. And so that's where I am right now. A pleasure to be back here. What I want to talk about is I want to talk about planet Mars, and I want to talk about the moon. And on this chart, it shows what are perhaps the most interesting objects in the solar system. These are the objects in the solar system that have solid surfaces, that are rocky objects. And we know that Jupiter, Saturn, Uranus, and Neptune are large balls of gas. And there's no evidence that there is a surface on Jupiter, Saturn, Uranus, or Neptune. So the odds are of humans exploring these gaseous giants are very remote. But we do know that the other objects that you're looking at right now, the Earth, Venus, Mars, our moon, the large satellites of Jupiter, Ganymede and Callisto, Io and Europa, the large satellite of Saturn, Titan, are all objects that NASA is either planning to send missions to or has already sent robotic missions to. So what I want to start to talk about is I want to start with the moon and then go to Mars in the talk. As you all know, because Langley Research Center had a major role, in fact, the architecture for sending humans to the moon was developed at Langley Research Center by, the original idea was John Hobalt, who was an engineer here for many years, and it's called Lunar Orbit Rendezvous. And that's how we got to the moon. As you know, 50 years ago, we had 6 missions. We had 12 humans for the first time actually walk on the surface of the moon and return safely to Earth. I'll talk more about this in a few minutes. This is an iconic picture of the second human on the moon. This is Buzz Aldrin. and it was taken by Neil Armstrong, the first man on the moon. And this is clearly, you can see Neil Armstrong's reflection in the helmet visor. Armstrong was not in many photographs. In fact, if you look at the catalog, there's only one that identifies him by himself on the surface of the moon, but there are many of Buzz Aldrin. This is another very iconic image. This is a boot print of Buzz Aldrin on the surface of the moon. And this boot print is very interesting because of how it's formed and what it means. And it will end up being one of the central things I'll be talking about. Let me say something about the first human landing on the moon. There was a group of world-class historians, and they were asked towards the end of the 20th century, what was the most significant achievement of the 20th century? And historian Arthur Schlesinger Jr. said that the one thing for which this century will be remembered 500 years from now was this was a century when we began the exploration of space. And he picked the first landing, Apollo 11, as the most significant event of the 20th century. Now, as I said twice already, Langley Research Center made important contributions to this event. On September 12, 1962, President John F. Kennedy, speaking at Rice University, gave a speech, Sending Humans to the Moon, Why We Should Do It. And an interesting point was made about this speech in a book that was published on the 50th anniversary of Neil Armstrong and Buzz Aldrin's landing. The book is by Charles Fishman, who's written several best-selling books. It's called One Giant Leap, The Impossible Mission That Flew Us to the Moon. And let me tell you what Charles Fishman writes in the first chapter of the book. When John F. Kennedy asked Congress to send Americans to the moon before the 1960s were over, NASA did not have plans, tools, or equipment to send humans to the moon and return them safely back to the Earth. NASA did not have the rocket to transport humans to the moon. NASA did not have the launch pads to send humans to the moon. NASA did not have the spacesuits to protect them in space. NASA did not have the needed miniaturized computers needed for the journey. NASA did not have the microgravity food needed for the journey. NASA did not know how to reach the moon. We didn't have an architecture, how you got there and how you returned safely. NASA did not know what humans would find on the moon. For example, and this is my addition, lunar dust. And when I read this in the book, I began to be very interested in the history of the Apollo program, and particularly what Langley Research Center has done. I spent about a year doing research, and just about a week ago, in the Journal of the British Interplanetary Society, which is the oldest journal dealing with space-related activities, they accepted my paper, and it will be out in July, around the anniversary of the first landings. And it was very instructive doing this work to find out what Langley Research Center actually did. The reason we're interested in the moon is we're going back to the moon. There's a NASA program called Artemis. Artemis is a twin sister of Apollo and the goddess of moon in Greek mythology. Artemis personifies our return to the moon as early as 2024. Originally it was 2023. It slipped at least a year. When we land a human on the moon after 50 years, Artemis astronauts will step foot where no human has ever been before, the south pole of the moon. And we will establish a permanent presence of humans on the moon at the South Pole. And Artemis will begin the next era of exploration with the horizontal goal of sending humans to Mars. And I'm going to talk about both things. Here is the National Space Council Policy Directive, SPD-1. The National Space Council, which is chaired by the Vice President, is responsible for overall direction for NASA activity. And it says, in keeping with Space Directive number 1, NASA is charged with landing the first American woman and the next American man at the South Pole of the Moon by 2024, followed by a sustained presence on or around the Moon by 2028. So by 2028, we're going to have a permanent presence on the Moon. Why are we going back to the Moon? This is the official National Space Council, and number 1 is establishing American leadership and strategic presence on the Moon. But I think the second one is really the overriding reason: to provide technologies and capabilities for sending humans to Mars. 3, inspiring a new generation and encouraging careers in STEM, science, technology, engineering, and mathematics. Expanding the U.S. global economic impact and broadening U.S. industry and international partnership in deep space. And this is how NASA sees the return to the Moon, the Artemis program. You see the Moon in the sky, but look at the reflection in the lake. It's Mars. And here's another, this is actually a NASA chart showing Earth to the Moon to Mars. Now, we're not going to send astronauts to Mars from the Moon. We'll use the Moon to learn how to live off the land. So do it on the Moon first. Partial gravity. Moon's gravity is about 1/6 g. Mars is about 1/3. Learn about the radiation environment without radiation belts protecting the planet as we have on Earth. And we'll learn about planetary protection. Let me start by giving, this is a verbatim transcript of Neil Armstrong's comments on July 20th, 1969. This is from the radio transmission. I am at the foot of the ladder. The lunar module footpads are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder down there. It's very, very fine. I'm going to step off the lunar module now. And then the famous, that's one small step for a man, one giant step for mankind. The surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers like powdered charcoal to the sole and sides of my boots. I can only go in a small fraction of an inch, maybe 1/8 of an inch, but I can see the footprints of my boots and the treads of the fine sandy particles. Neil Armstrong at that point did not realize the impact of that fine powdery substance 1 to 2 inches on the surface of the Moon. And let me tell you about the impact. Eugene Cernan, Apollo 17, was one of the last 2 humans to walk on the surface of the Moon. His partner was Jack Schmitt, Harrison Schmitt. And this is a quote from the debriefing of Gene Cernan. I think dust, the lunar dust, is probably one of the greatest inhibitors to a nominal operation on the Moon. I think we can overcome other physiological or physical or mechanical problems except dust. One of the most aggravating, restricting facets of the lunar surface exploration is the dust and its adherence to everything, no matter what kind of material, whether it be skin, suit material, metal, no matter what it be and its restrictive, friction-like action to everything it gets on. Just a final quote from Alan Beam, Apollo 11. After lunar liftoff, a great quantity of dust floated free within the cabin. The dust made breathing without the helmet difficult, and enough particles were present in the cabin atmosphere to affect our vision. The use of a whisk broom prior to ingress will probably not be satisfactory in solving the dust problem because the dust tends to rub deeper into the garment rather than to brush it off. There are 9 different problems that have been identified by the astronauts because of lunar dust. 1, visual obscuration. Now, you've all seen the pictures of the Apollo astronauts landing. If you remember in Apollo 11, about 150 feet above the ground, the rockets on the lunar module working against the surface dust resulted in total obscuration of the surface. You could not see the surface. 2nd, false instrument readings. 3, dust coating and contamination. Loss of traction when you walk or you drive a lunar vehicle. Clogging of mechanisms. Abrasion. Now, this abrasion is a real serious problem because after 1 or 2 walks on the surface of the moon, there was so much abrasion. The dust is glass, very, very fine glass, 50 microns or less, and it causes tremendous abrasion on the spacesuits, on all equipment. Number 7, thermal control problems. Number 8, seal failures. And number 9, perhaps the most serious from a medical perspective, inhalation and irritation. The stuff is so fine and it gets in everywhere. A brief introduction to dust on the moon. You shouldn't breathe it in. It wears through spacesuits. Let me follow that up. You shouldn't breathe it in. Astronaut Harrison Schmitt noticed the smell of dust in the air like gunpowder. A pathologist at NASA Ames, Russell Kirschman, warned that prolonged exposure to moon dust can seriously damage human lungs. It wears through spacesuits. Moon is very dusty. Moon dust is very abrasive and clingy. Apollo 17 astronauts had problems moving their arms properly because lunar dust had clogged up the joints while it wore through 3 layers of Kevlar-like armor on Harrison Schmitt's moon boot. It's mostly glass. It's made up of fine microscopic particles of silicon dioxide glass plus iron, calcium, and magnesium, as well as other trace minerals. It's been shattered and ground into a fine powder over billions of years of meteorite and micrometeorite impacts. Astronauts have actually tasted it. Apollo astronauts have touched, smelled, and even tasted moon dust. It is as fine as flour, but extremely sharp and abrasive. I repeat the word abrasive for emphasis. No, it's an error. Plus, it both smells and tastes like gunpowder. It is extremely clingly and very hard to brush off. Now, you know you have a problem when there's a section in Wikipedia about the topic, and there's a 15-page article in Wikipedia called Adverse Health Effects from Lunar Dust Exposure. Now, when I learned about Artemis, this is after my retirement from NASA Langley, I remembered the problems we had with lunar dust. And I decided that someone had to get involved with this problem. And I wrote an unsolicited proposal to NASA to have an international workshop called The Impact of Lunar Dust on Human Exploration at the Lunar and Planetary Institute, which is on the campus of Johnson Space Center in Houston. And that meeting was from February 11th to February 13th, 2020, just 1 month before the COVID pandemic was identified. The College of William and Mary got as sponsors NASA's Engineering and Safety Center, the Lunar and Planetary Institute, where it was held, University Space Research Association, a place on the West Coast called Jet Propulsion Laboratory. I served as convener, and the organizing committee consisted of myself, Daniel Winterhalter, chief scientist at JPL, and Russell Kirschman, who's an Ames pathologist who's very knowledgeable about medical effects of dust. We had 3 panels. Panel 1, lunar dust, its composition, structure, and distribution. I served as a moderator, and a student of mine at William and Mary, Max Weinhold, who's at that time a senior, served as a recorder. Then we had panel 2, the impact of lunar dust on human health. Russ Kirschman, the pathologist, and Peter Sim is a resident of Williamsburg, a good friend of mine. He just retired as a senior doctor in the emergency room at Riverside Hospital. And when I was briefing NASA about this at Langley about a year before the meeting, someone said, well, Peter Sim, I'm not familiar with the work he's done. And I said, God forbid, if anyone in this room has a heart attack in the next 3 days, you'll meet Peter Sim as they take you to Riverside Hospital. And panel 3 was the impact of lunar dust on human surface systems and operations and techniques and technologies to reduce mitigation. And the panel members were Winterhalter, Daniel Winterhalter, JPL, and Michael Johansson, who's at NASA headquarters. And Michael Johansson was given a large sum of money from NASA to come up with technologies and techniques to reduce and mitigate dust during the Artemis era. And Michael played a key role at our meeting and took copious notes. And we are now funding, NASA is funding the ideas that were discussed at the meeting. Again, the sponsors, I told you who the sponsors were. And the result was the publication of this book, The Impact of Lunar Dust on Human Exploration, a series of 14 invited chapters by the world's authority in dust, medical impact, and medical health and mission and service operations. This book was just published. It's published by Cambridge Scholars Publishing in England. Here are some of the conclusions in the book that we have to find out before we can successfully send humans back to the moon. And prior to the first human landing in 2024, the first Artemis human landing, there are going to be a series of robotic missions to the surface of the moon, maybe as much as a dozen. And we have developed a scenario where most of these questions will be answered. What are the particle distribution, mineralogy, and chemical composition and possible toxicity of lunar dust, especially for particles less than 50 microns? Number 2, what processes and mechanisms control the transport and dynamics of lunar surface dust? What are the electrical and magnetic properties of lunar dust? What techniques and technologies are needed to reduce/mitigate lunar dust impacts on the astronauts, their equipment, habitats, and spacecraft? One of the reasons that Artemis is delayed by 12 months is that the company that's building, constructing, and developing the new spacesuit that will be dust resistant told NASA they need an extra year to do it. And those people were at our meeting, heard what the problems are, and a result of that meeting, their bid was selected, their proposal selected, and they are building the spacesuit. Let me go from one object that begins with M, called the moon, and start with the second part of the talk with another object that's name begins with M, and that's planet Mars. This is the design reference architecture that was published in May 2009 for sending humans to the moon. It's a NASA SP. It's online. You can download it. The chief engineer on this was someone named Drake at Johnson Space Flight Center in Houston. This is the back cover. Now, President George Bush announced in 2014 that a national goal of the United States of America would be sending humans to Mars and returning them safely. And he actually came to NASA headquarters, first time a sitting president of the United States showed up at NASA headquarters to give a press conference. And Bush said, we're going to do this. And someone during the question and answer period said, that sounds very good. What are the scientific reasons for sending humans to Mars? Are there scientific reasons? And President Bush said, well, I'm president of the United States. I don't know everything, but the NASA administrator, and I won't mention his name, who is standing to my left, knows the answer. Well, the NASA administrator to his left had been the head of the Bureau of the Budget a week earlier or 2 weeks earlier, didn't know. And it was a little embarrassing. As a result, NASA formed a panel called HEMSAG, Human Exploration of Mars Science Analysis Group. Jim Garvin, the chief scientist at Goddard Space Flight Center, and I were asked to co-chair that panel and to pick the panel. And this is the panel we picked. I was on detail to NASA headquarters as program scientist for the Mars Scout program and the Mars Exploration program, Science Mission Directorate. And that was half my job. The other half of the job was to co-chair this panel. And the results of this panel, we met for several years to address the question, are there scientific questions that cannot be addressed by robotic missions over the next 50 years that justify human missions? And our report was published as a NASA report. It was 100 pages, but the details, what led to that report, all of our white papers in our panel of 30 people on the panel, ended up in 956 pages of journal articles in the Journal of Cosmology, which the Journal of Cosmology later turned into a 976-page book. And this is it. Rudy Shield, my co-author, is professor of astronomy at Harvard University, and he's the editor-in-chief of the journal. And so all of our deliberations are in this book. And in that Drake report on design reference architecture for sending humans to the moon, we're like the first 3 chapters. That's taken from our HEMSAG report. Let me say something about Mars. Mars is a very dusty place. This is a picture, these are 2 pictures taken with the Hubble Space Telescope, and they're taken 1 month apart. And on the one on the left, you can see down to the surface. Then a few weeks later, there is a planetary-wide dust storm over Mars. You cannot see the surface. This is a series of pictures just taken by Perseverance, the rover Perseverance on the Mars surface, and you can see the dust rising on the surface of Mars and obscuring the planet. This, again, this picture is probably a month old, but you can see how dust is filling up the atmosphere of Mars. Now, this is a lander, a probe called InSight. InSight, Jet Propulsion Laboratory did this mission, and what they're supposed to look for is Mars quakes. And this is the solar panel. And NASA just announced this week that because of so much Mars atmospheric dust landing on the solar panel, this is dying right before our eyes. The InSight experiment is losing all its power because of the continuous bombardment of fine dust. And you can see that when we look at the top of the solar panels, it's the same color as the surface of Mars. And they say it may be within a month that it will lose all of its power. Now, this is a very interesting chart, and actually the bottom part of the chart was developed at the NASA Langley Research Center. Let me talk about the bottom part first. That shows the opacity, or the thickness of dust in the atmosphere from Viking Lander 1 from 1977 to 1978. And the chart is divided into seasons. The bottom, you can see it says southern winter, southern spring, southern summer, southern fall. Then on top, it says northern spring, northern winter, northern fall, and northern summer. Notice in the southern spring and southern summer, which is the same as northern fall and northern winter, that the orange marks, that's a measure of the opacity. Now that little horizontal line halfway through is the level at which it's difficult to see the sun's disk in the dusty sky. So once you get above that opacity, and it's just due to the fact there's so much dust, it's absorbing incoming sunlight, that halfway up, you can't even see the disk of the sun in the sky. That's a dusty place. And on top, the chart shows when dust storms tend to appear. Dust storms beginning in 1901 and 1977, 1982, 1956, and so on. Most of the dust storms begin and develop in the southern spring or northern summer, and that's where the bulk of them take place. So you can see the effect of this dust. There's so much dust on the atmosphere of Mars, it blocks out the sun, so you cannot see the sun. Now, I have a series of pictures of dust devils on the surface of the moon, just to show you. This is Mars Reconnaissance Orbiter. This is a dust devil that goes up about 10 miles into the atmosphere. You can see its shadow. Here's another one. I'll just go through these fast. You can see this dust devil with its shadow. Now, this is a video. This is Mars Exploration Rover Spirit. That's Steve Squires at Cornell University was principal investigator of this. He was on our HEMSAG team, and the Mars Exploration Rover Spirit and Opportunity took dozens of videos of these dust devils. Here's a still shot taken from MER, Mars Exploration Rover. Now, here you can actually see the dust in a dust devil. You can see its shadow because I guess the sun is off to the left, and you can actually see the tracks of it on the surface of Mars. This shows the tracks. This is from Mars Reconnaissance Orbiter. It shows the tracks of dust devils over a several-week period. This is an actual photograph from Mars Reconnaissance Orbiter. Here's another one where you can see tracks of these dust devils. This is almost looks like modern art, showing the sand dunes, and you can see all of the dust devil tracks. It's like modern art. Now, in 2017, we held our first conference on planetary dust, the second one being lunar dust. This was called Dust in the Atmosphere of Mars and Its Impact on Human Exploration. The same cast of people. We had the international community at Lunar and Planetary Laboratory. We published the results in a book, Dust in the Atmosphere of Mars and Its Impact on Human Exploration. And this is based on material in the book. These are some questions that have to be addressed before we can send humans to the surface of Mars. What is the chemical composition of Mars dust, including the identification of possible chemically reactive and toxic compounds and metals? We know that there are perchlorates on the surface of Mars. That was discovered by one of the landers called Phoenix in 2008, the presence of perchlorates, very chemically active material, very bad for oxidizing, like the thyroid in the lungs. Plus, we know about very highly toxic metals, particularly hexavalent chromium that's on Mars, and these are very detrimental to humans and human respiration. Second, the electrical nature of Mars atmospheric dust and how potential electrical charges on dust particles may be dissipated. Three, how to better predict the occurrence, location, and severity and duration of dust storms. We have about 100 years record of where the dust storms are, how long they last, latitude, longitude, duration, and we're going to have to plan to send humans to an area that is not known for its large dust storms, and also to better understand the impact of Mars dust in human respiration in a reduced gravity environment over extended periods of time on the surface of Mars. One of the things that we learned from both of our workshops, the Mars dust workshop and the lunar dust workshop, is that in low gravity environments like the Moon 1/6G and on Mars 1/3 G, there are more problems of inhaling these small particles, dust particles. So it's become very important. Here's my favorite recommendation. To better understand the role of the omnipresent atmospheric dust on Mars in the potential transport of Earth microorganisms around Mars, that's called forward contamination. You know, on Viking, 1/3 of the budget, 1/3 of the total budget was used to sterilize the landers. That's a lot of money. And unfortunately, all the spacefaring nations that have landed on Mars with robotic missions have not taken the time and the work and the expense to sterilize their equipment. So we're really worried about forward contamination of Earth microbes going around Mars, and they can travel large distances on Mars dust. But the second problem is the role of atmospheric dust in transporting possible Mars microorganisms back to Earth with the astronauts and their equipment. That's called back contamination. Remember the hit movie and best-selling novel Andromeda Strain? Well, we don't want Andromeda strains. And if there are if there are microorganisms on Mars, we have to be very, very careful about back contamination. I believe one of the reasons we're doing the Mars sample return, which is on the calendar. Perseverance is going to pick about a dozen samples, put them in sterilized tubes, and in the near future, within the next 5 to 10 years, a spacecraft will pick up these sealed containers with samples and bring them back to Earth. I believe that we're doing the Mars sample return, or the strongest scientific justification for Mars sample return is to know if there is active life on the surface of Mars before we send humans there. And I think that we will know. Let me conclude with two things. Steve Hawking, I think the human race has no future if it does not go into space. Carl Sagan, a Viking Project scientist, was fond of saying, the dinosaurs became extinct because they had no space program. And I will end my talk within my allotted time by 15 minutes, Vicki, with a video that I had prepared by a graphic artist for my 2015 TED Talk. And
2, 1.
This is a virtual trip to Mars and back.
The dawn of Orion and a new era of American space exploration.
That's an actual launch. Everything else is artist conception. This is the transfer vehicle that goes from Earth orbit to Mars. This is a scenario in Brett Drake's design reference atmosphere. The video oversimplifies entry, descent, and landing. It's not as easy as it looks here, but this is a schematic, a cartoon. The astronauts will look around. The latest feeling is it will be a 30-day mission, and there will be 4 astronauts, 2 on the surface and 2 in orbit. Let me just conclude with one or two comments. I think one of the great things about working at NASA Langley Research Center for 41 years was the enthusiasm, the knowledge, and dedication of the Langley employees in all divisions, in all areas. It was just a great pleasure working with these people. And what I'm pleased to tell you, after spending the last 11 years as a professor at the College of William and Mary, working with some of the smartest students in the country, that enthusiasm is there. The majority of my students would say yes if asked would they like to be the first human on Mars. They are turned on to Mars. They are turned on to space. They like what NASA's doing. They like the U.S. space program. So it's very nice working with them. Those who know me, like Ed Pryor sitting here, who was my first office mate, knows that my hair is now about 3 inches longer than during the 41 years I spent here at NASA Langley. That's because the people I work with now, I have long hair. Anyway, I want to thank you for coming. I appreciate it. And I think Vicki said there may be some time for questions if I finish 15 minutes before. Vicki, I did.
Yes, you did. Thank you. Yay. That was a terrific talk, Joel. I got an amazing set of comments about the overview, and everyone wants to make sure that we celebrate this trip to Mars and what we're learning at the moon with you. I do have a couple of questions online, and then I'm hoping either Rick or Dan can ask a couple questions there in the room. All right, so your talk and your video as well actually addressed a couple of these questions, but you can probably elaborate. One came from Tucker Ewan, and he said with the trip to Mars, the human trip to Mars, we're learning a lot, as you pointed out, by through Artemis and going back to the return to the moon. Is the moon going to serve any other purpose in our exploration other than that learning? Is it going to be used any as a refueling point or anything else along the way?
Well, that's a very, very good question. And it's very, very relevant because just 1 week ago, from today, NASA's Engineering and Science Center, NESC, located at NASA Langley, ran a 3-day workshop dealing with unique science that can be obtained during the Artemis program. We're going back to Mars, so we learn how to live off the land. We learn how to work, with materials that are there. But what NASA people have said, we're going back to the moon. Is there any science that we can do that we haven't done yet? And what's emerging based on this NESC workshop, which was just 1 week ago, is using the backside of the moon as a center for radio telescopes. Within craters that are already there, build radio telescopes. And it's the quietest environment. Now, this is the side of the moon not facing the Earth, the far side. And there have been a half a dozen proposals by some of the major universities and NASA centers to build astronomical radio telescope observatories on the dark side of the moon. And that was one of the areas that was discussed. So I think now that NASA realizes we're going back to the moon to learn how to live on another celestial body for extended periods of time, but there are some good science that can be done. And so NESC is going to hold a series of workshops over the next year looking at some of these things. So there appears to be some good science that can be obtained uniquely from the moon.
Wow. Okay. That's what we would expect. And I know we'll learn more, especially, given the delay. That just gives us more time to prepare. So when we were talking about the dust, we've had a number of samples and they've been investigated. You talked about, it'll be another 5 years or more before we get the actual samples back from Mars. So that which we've already investigated, is it giving us a feel for what dust is like across the moon or just in particular regions where we intend to habitat in our return? Do you know?
I think that the moon appears to be uniform in that covering most of the moon's surface, there is this 1 to 2 to 3 inch of this very, very fine dust that is glass, actually. And we've sampled dust at 6 different Apollo sites, and it turns out there's this glassy dust everywhere. So I think we have a good handle on the dust and its characteristics. What we don't have a good handle on right now is how to build a spacesuit and a helmet that will not be corroded by the stuff. But I understand, I have not seen them, but I understand the proposals were very, very good, and that there's some competitive ideas out there, and that, when we did Apollo 11, we didn't worry about the dust. That's one of the things that Charles Fishman says. We didn't know what we would find on the surface of Mars, on the surface of the moon. Thomas Gold, a very famous astronomer at Cornell University, predicted in a peer-reviewed paper that Apollo 11, when it landed, would sink in 10 feet of dust. Now, he was off by several feet, but the whole surface of the moon has this very interesting dust that's very worrisome and very a nuisance.
So yeah, so that's been part of a number of the questions as well. And you hit on the spacesuits, which a number of people were concerned about. So we're sending out. I gather from what you just said. I guess we've asked for um, folks to let us know what they believe changes need to be made, and they're making recommendations. So we've got contracts going out. Is that what you're
Yes,
telling us?
well, yes, Michael Jorgensen
Okay.
at NASA, Johansson rather, at NASA headquarters has let several dozen contracts of ideas that were developed at the Lunar Dust Workshop,
Oh,
which was just a year ago. And we had 250 people. We had astronauts. That's why we had it at Lunar and Planetary Institute. They're on the center, on Johnson Space Center, so the astronauts can walk in and they don't need travel and they don't need hotels and they don't need rental cars. That's why NASA wanted us to have it there. I wanted to have it in Williamsburg because it would be a good experience for our students, but NASA said no. We want the astronauts there, so this way they can just drop in, and they did.
oh,
And
that's great.
it was very exciting.
Okay, so I've got another question about the dust, the magnetic properties that are being found in the dust. It could make it combustible in a normal atmosphere. Do we know that?
One of the very first things, perhaps the first thing that Neil Armstrong and Buzz Aldrin did when they got to the moon on July 20th, 1969, is Neil took a bag full of moon dust and then took it back in the cabin after their first walk down the ladder. And the idea was to see if that combusts in the lunar module. And so he and Buzz watched this very closely, looking for it to get hot and combust, and it didn't. It had been suggested that because of the lack of oxygen in the lunar environment, that this stuff may combust. But the stuff that was brought back to Earth didn't combust. The reason we have to know its magnetic properties, which we don't really, and its electrical properties, which we don't know really, is because some of the mitigation techniques are based on magnetic effects and electrical effects. But we don't really know the electrical effects and magnetic properties. But prior to the first Artemis landing of humans, there are going to be a series of commercial missions, and they understand what we need to know about lunar dust. And I think we'll find that out once we start getting the first robotic missions.
Great. Okay, I still have a couple of questions, but I want to go to the room because I want to be fair here. So Dan or Rick, could you manage questions in the room for a few minutes?
15 years ago and more, you were leading a Mars airplane effort here. And you put together a really great team of scientists, and there's always judged category 1 science, but is very highly regarded as a science mission. And in the intervening years, there have been a lot of missions to Mars to do science. So I've always wondered, are there certainly the crustal magnetism is still there, but what parts of the Ares science story are still open questions after all these follow-up missions?
That's a good question from Gary Qualls, who's still working here at Langley and was one of our key engineers on the Ares proposal, which, as he said, was rated very highly. It turns out that when we look at our science objectives, crustal magnetism, atmospheric chemistry, those questions have not been solved yet, and we have had discussions about resubmitting Ares. We submitted Ares to the first Mars Scout, and we were one of the 4 finalists, and eventually Phoenix, University of Arizona Stationary Lander won. And then we submitted it a second time to Mars Scout 2, and unknown to us, NASA decided, even though they got 30 proposals, that they wanted one to study the upper atmosphere of Mars. Ours was a lower atmosphere experiment. Even though we got higher grades the second time around, the Langley experiment, it was developed here at Langley. Henry Wright and Mark Kroom were some of the key people. Henry just retired. Mark Kroom, after he retired from NASA, he decided to get a PhD, and he's at the University of New Mexico right now getting a PhD in chemistry. And we've had talks. We've had talks with Goddard, who were our partners on this thing. Jim Garvin, the chief scientist, was on our team. Jim Head was on our team. And everyone is still very, very interested. I have personally spoken to Jim Green, who just stepped down as the chief scientist at NASA. He was he had a planetary program office for many years, and he's very interested in that. I think we just have to see the opportunity. The main problem with Ares from a NASA perspective is this: when you we decided we would have an orbiter and then we would have an airplane, and that's expensive. And all of these are budget limited, usually $500 to $600 million. Very difficult to come under the cap. And that was our problem for follow-ons. But I can say there is interest, and who knows what the future will bring. Good question, Gary. And I didn't put him up to that.
Do we have more time, Vicki, or?
Dan, you probably have time for one more question in the room, and then it's all up to you. We've got like 3 minutes to one.
In which case, I have a question. So, you wrote, or in your book, 900 some odd pages, answering the question I've always had about whether there are anything that humans could do that robots can't. But you never gave us the punchline.
The punchline, to save you, it's actually 976 pages. It turns out that after meeting, we had 30 of the top Mars scientists in the world. That was our charge. We picked them, and everyone we asked agreed to work with us. So everyone we asked agreed to work. We worked for over 3 years, and the punchline was there are two overarching questions that, in the opinion of the Mars scientists and the technologists on our panel, that cannot be answered by robotic missions. The first question is there life on Mars today, or was there life in the past? And answer that question unambiguously. And it was the consensus of the panel that you cannot do that robotically. The second question, when Mars was formed 4.5 billion years ago, it was a Tuesday. That's the same day Earth was formed, the sun was formed. Mars was a miniature Earth. Mars' northern hemisphere had oceans 5 miles deep. Mars had a very, very thick atmosphere. Something happened along the way, and Mars was transformed into a very inhospitable, cold planet with no surface liquid water and an atmosphere that at the surface is like the Earth's atmosphere is 100,000 feet. That's the beauty of Ares. We developed an airplane in the wind tunnels here that could fly at 100,000 feet. Why did Mars go from an Earth-like object to a very inhospitable place? And we could not project that within the next 50 years, those two questions can be done unambiguously. Now, if you want the detailed answer, I can give it to you in 18 minutes. Look under TED Talks, Levine, 2015, and you'll get the answer in 18 minutes. Good question.
Yeah. Thank you. I think, Vicki, that's it.
Yes, sir. It's all up to you.
You get to have a LAA mug.
Oh, I've always wanted one. Thank you.
Thank you very much.
Thank you very much. Thank you.